Hello and welcome to Flat Out Helpful. My name is Jared, and in this video we're going to be doing something a little bit different. This is going to be the first space science related video, so we're not going to be taking a look at Flat Earth. In this video we're going to be taking a look at the Japanese Venus Climate Orbiter. We're going to be taking a look at the spacecraft, its mission, the science that it's doing at Venus, and we're going to be taking a look at its interesting connections to Japanese pop culture. So, without any further ado, let's get started. The Venus Climate Orbiter, also known as Akatsuki, which translates to dawn, is a very interesting spacecraft, not only because it almost didn't make it to Venus, but because it also carries a unique piece of Earth culture with it. Akatsuki was built by the Japanese NEC Corporation and has a scientific suite of 6 instruments, 5 of which are imaging cameras and the other being an ultra-stable oscillator. The reason the probe has mostly cameras for scientific instruments is in the name, Venus Climate Orbiter. It is basically like a weather satellite for Venus that makes detailed observations of its clouds and atmospheric structure. As you can see in this infographic, it shows what each camera is supposed to observe. The first camera is the ultraviolet imager, or UVI. This is used to look at the sulfur dioxide, which is related to cloud formation and the distribution of some unknown substance that absorbs UV rays. It can also measure the wind speed at the top of the clouds. The next 2 cameras are the 1 micrometer and 2 micrometer cameras. These both image in infrared and are named IR1 and IR2 respectively. IR1 looks below the clouds into the lower atmosphere to observe the distribution of water vapor, the mineral composition of the surface, and can look for the presence of active volcanoes. The IR2 camera looks at around the same regions IR1 does, but it looks at the makeup and density of the clouds, as well as the lower atmospheric circulation, giving insight into cloud formation. IR2 also observed the zodiacal light, which is sunlight reflecting off the interplanetary dust in our solar system. The IR1 and IR2 cameras also operate at the most wavelengths out of the other cameras, with IR1 using a lower end of the 1 micrometer wavelength and IR2 using the higher end of the 1 to 2 micrometer wavelength. Second to last is the long wave infrared camera, or LIR. This one uses just a 10 micrometer infrared wavelength to look at the top of the clouds, observing convection of the upper layers as well as wind speeds. Finally, there is the lightning and air glow camera, or LAC. This camera can detect high-speed brightness changes up to 1/30,000th of a second, which helps it look for lightning. It can also observe air glow from oxygen at around 100 kilometers above the surface. This air glow is quite fascinating as it is caused by UV radiation from the sun breaking apart CO2 on the day side, of which the resulting oxygen atoms get carried around to the other side of the planet to form back into O2, emitting a strong infrared light. Now, there is an instrument which is not a camera. It's called the Ultra Stable Oscillator, or USO. What this instrument does is it sends out a constant beam of radio waves to Earth. As they pass by the planet and through the atmosphere, the wave frequencies are affected. These changes can be used to measure vertical profiles of temperature and sulfur acid vapor in the atmosphere. The launch of Akatsuki was on the 20th of May 2010 from the Tanegashima Space Center on an H-IIA rocket. The launch went off without any problems, and it would not be the cause of the issue that would develop later on. The highest quality video of the launch I can find is this one that looks like it was shot from an airplane. It also gives you a nice perspective on just how fast this rocket is going. However, there was another JAXA payload along for the ride. The secondary payload was called Icarus, or the Interplanetary Kite Craft Accelerated by Radiation of the Sun. Icarus would become the first solar sailor to use the sun's energy as its main propulsion. It would demonstrate this on its way to Venus in tandem with Akatsuki. On its way to Venus, it would begin spinning to generate centrifugal force to open the sail, which was quite large at 196 meters squared, or 2,110 square feet. For reference, that is about the size of a large 4-bedroom house in the United States. Here is a photo of this sail fully extended, which was taken by one of the 2 ejectable cameras that were made to take photos of the extended sail. Relating to the science of it, the solar sail was calculated to have generated 1.12 millinewtons of thrust. As of now, the last communications with it were in 2015, and it is currently in a heliocentric orbit. Akatsuki would not have the luxury of a smooth mission, however. Come December 6, 2010, it was time for the probe to make its 12-minute orbital insertion burn. This was to place it into an elliptical orbit with an apoapsis of 180,000 to 200,000 kilometers, or 110,000 to 120,000 miles, and a periapsis of 550 kilometers, or 340 miles. The insertion burn started on time, and then came the expected blackout in communications from Venus being in the way. But the probe did not recover as planned after the communications blackout. The probe was found to be in a safe hold mode, and it turned out that the orbital maneuvering engine only fired for 3 minutes, which was not enough to put the probe into orbit around Venus. This is a graph of the acceleration history during the burn, and you should be able to tell something is wrong immediately. As the fuel is depleted, the acceleration should increase as the spacecraft weighs less and is still outputting the same amount of thrust. But the acceleration begins to slowly drop off right after the start of the burn, and at about 2.5 minutes in, there is a big drop off in thrust, which is right before the engine shutoff. This graph shows a drop in fuel pressure over time, which is a key detail as to what caused this. There was a blockage formed in the valve between the helium tank and fuel tank, causing it to slowly lose pressure. This in turn started making the engine run more oxygen rich, which makes it hotter. In the end, the engine bell suffered severe damage, leading to a loss of thrust, and the engine shut down at around 3 minutes. Now, the reason the probe's computers shut the engine off at 3 minutes was not because of the loss of thrust, but because the spacecraft was beginning to gain an unwanted rotation on the x-axis. When the rate got up to 12 degrees per second, the fault protection system sensed something was very wrong and shut down the engine, leaving the Akatsuki to sail right by Venus. This unwanted torque was likely caused by the ceramic engine bell fracturing at the throat and causing part of the engine bell to break off. Later in the burn, the unwanted velocity began to decrease, hinting that the entire engine bell was now gone. This was confirmed with later test firings revealing it operating at 10% nominal thrust, basically making it useless. All was not lost, however, as the probe still had its reaction control system thrusters. A decision was made to dump the OME's fuel as it was not needed anymore and would lighten the spacecraft. It would be another 5 years before Akatsuki would be able to catch up to Venus and try for another orbital insertion. However, the plan to go into low Vesuvian orbit had to be abandoned as the reaction control thrusters were not able to do this, and it would have to remain in a highly elliptical orbit. On December 7th, 2015, it made a 20-minute burn to insert itself into an orbit around Venus. On December 9th, it was announced that Akatsuki had successfully entered into orbit around Venus, which at its highest point was 440,000 kilometers or 270,000 miles from Venus, and at its closest was 400 kilometers or 250 miles. A follow-up thruster burn on March 26, 2016, lowered the maximum orbit height to about 330,000 kilometers or 210,000 miles. Even though it was not the intended low Vesuvian orbit originally planned, the orbit it was in was still suitable for doing science. This year is a movie of synthesized false color images of Venus acquired by the UVI ultraviolet imager from November 16th to December 7th, 2018. This night side view of Venus was imaged by IR2 and is to date the most detailed global view of the night side disk. It really gives you a good idea of just how complex the thermal movements in the atmosphere are. One of the most interesting finds is what is called a gravity wave, not to be confused with the much different gravitational wave. It appears as a big, bow-shaped feature that stretches across 6,000 miles. This is thought to occur over the Aphrodite Terra, a highland region the size of Africa that rises up to 3 miles above the surface. For reference, Mount Kilimanjaro is about 3 miles high, and it is also in Africa, so imagine that, but the size of the entire continent. It is thought that the wind flowing over this gets pushed upwards, resulting in a gravity wave that is warmer than the air around it, making it visible in infrared. For more images and science related to the mission, I'll put a link to JAXA's webpage for the mission in the video description. Finally, we arrive at the public outreach for Akatsuki. There was an event to submit your name and have it put on metal plates used for balancing the spacecraft. That got 260,000 applications with the names etched on 90 different plates. Here are some photos of the plates and the installation of the plates onto the spacecraft. It's surprisingly hard to find any good photos of this stuff despite it being from only 10 years ago. I have run into many dead links and websites searching for these, and this was the best I could get. However, there was 3 plates in particular that got something a bit more special on them. There was a petition created by Somsat to put drawings of Japanese pop star and virtual singer Hatsune Miku on 3 of Akatsuki's metal plates. The petition reached over the 10,000 required submissions, and a contest was launched on PiaPro to solicit the artwork for the plates. Somsat, or Social Media Satellite, has been doing outreaches using Vocaloid and Hatsune Miku for a while now, and the trash weeb side of me finds this a unique and interesting way to get people interested in space exploration. Their grand goal is to launch a CubeSat with Hatsune Miku inside waving a leak around with a camera pointed at her. However, I think Somsat deserves its own separate video. So far, this is the most culturally specific thing that has been launched beyond low Earth orbit. Generally, things we send to deep space are more related to humanity as a whole, like the Voyager Golden Record or Pioneer 10 plaque. Speaking of which, my personal favorite image from the outreach is this parody of the Pioneer 10 plaque but with Hatsune and Hatsune Miku instead. Hatsune Miku is something very specific of Japanese culture, a somewhat fictitious virtual entity that sings songs and appears in video games. If aliens were to find those metal plates in orbit around Venus on Akatsuki, they would be in for quite a surprise when they finally get to Earth and nobody has giant anime eyes or twin tails. And that about wraps it up for this video. I feel like I have covered about everything in general. I'll put some links to the images that were used for the Somsat plates as well as a few other related tidbits in the video description if you care to look into this further. Oh! Well, looks like the video is over already. Hey, say, if you like to see me make more stuff like this, make sure to leave a like and subscribe. And if you want to support the channel, my Patreon link will be in the description of the video. Thank you so much for watching, and have a flat-out awesome day.